It is March and the annual NCAA basketball tournament's down to the final 4 teams. Randy Kitchell is a t-shirt vendor who plans to order a t-shirt with the names of the final 4 teams from a manufacturer and then sell them to the fans. The fixed cost of any order is $750. The variable cost per shirt to Randy is $8, and Randy's selling price is $18. However, this price will be charged only until a week after the tournament. After that time, Randy figures that interest in the t-shirts will be low, so he plans to sell any of the remaining t-shirts at $6 each. His best guess is that demand for the t-shirts during the full price period will be about 1,500. He's thinking about ordering 1,450 t-shirts, but wants to build a spreadsheet model that will let him experiment with the uncertain demand and his order quantity. How should he proceed? So if we take a look at this, if we go to NCAA t-shirts, we've already got some stuff built and put together here, so we can start putting together equations. Now you're going to see that we typically use this color coding format where blue are our inputs. These are the things that we know from a model. In this case, there's our 750 or 8 or 18, all that. Red are the decision variables. Decision variables are going to be important as we're looking through any of this stuff, because the decision variables are what we're responsible for figuring out, what we're trying to do. Gray will typically be the outputs, and in this case profit, because that's what we want to get. And lastly, green is going to be an uncertain parameter. In this case, it's going to be demand, which we can play around with. And so we can start building up a sheet to calculate this out for Randy. Now, one of the things that we can do is right off the bat, what I'm going to do is I'm just going to highlight all of these. I'm going to make range names for all of this stuff. And so I've highlighted everything. Everything has a name in the left row. And so we're going to go into formulas, create from selection, say left row, say OK. And then I'm going to come over here and just put my range names in. Not create from selection, use in formula, paste names, and we're going to paste all of them. It's just a good habit to do. So let's start building out some equations. And so the thing is, I've got costs and revenues in there. They really don't need something associated to that. So why don't we go into formulas? We're going to go into name manager. And we're going to find cost, which has no value. We're just going to delete it. And revenues is the other one because that's just a title. So we're going to delete that too. Now I can individually delete these, or I can paste them again. It's really pretty easy to do. There we go. I don't know why some of those are bold and some of those are not. There we go. That's the way I like having it. So let's start building the equations so we can figure out how we can help Randy out. So our fixed costs are going to just be our fixed costs, so that's pretty easy. And so our variable costs, what are our variable costs? Well, that's going to be, we have a individual variable cost, and then we're going to multiply it by the demand. Because that is what it's going to cost us to buy that many shirts. And then revenue. So this one this will be a little bit interesting because, well, how many full price shirts is he going to sell? Well, if I order 1450, but the demand is 1500, how am I going to sell? Well, it's going to be 1450. So what I want, but if the demand is 1,000 and he orders 1450, what's he going to sell? He's going to sell 1,000. So actually what I want is I want the minimum of whatever these two values are. Either the order quantity is less than demand, which means I can't sell any more because I've exceeded demand, or the demand's lower than the order quantity, I'm only going to sell up to demand. So this is what we're going to do, is we're going to say, well, let's do a minimum calculation. and tell me the minimum between this guy and this guy. And so what I did on that one is I held control, and that automatically put the comma in. That's B13 and B10. I actually don't want to do it that way because since I put the range name in, comma, I'll click on that, because if I don't do it that way, it's not going to be the range name. So that way it wouldn't change. Now, that is not correct because that's just giving me the minimum. That has nothing to do with cost. Now what I got to do is I'm going to take that quantity that I'm selling at full price and I'm going to multiply it by what the selling price is. So there we go. So if at that quantity, order quantity is minimum, multiply that by $18 per shirt. Okay, so now what am I going to do? Well, now I have to figure out what's left. Discount price. And this only happens if I have shirts left. So let's write an if statement. So our logical test. If our demand is greater than our order quantity, we're going to have nothing to sell at the discount price because there will be no shirts left. If that's false, if the order quantity is greater than demand, what we're going to have is we'll have the order quantity and we are going to subtract what the demand is. And that's going to tell us how many shirts we're going to have left over that we're going to be able to dump off at the discount price. So that equation that we have is either going to give me a 0 if the demand's greater, or it's going to give me the difference between the demand and the order quantity, and then I will multiply that by the amount that I'm selling the discount for. Once again, as you can see, as I wrote this equation, it's really easy to see the colors against the cells and whatnot, but having the range names in there makes things a lot easier for somebody to look at and see what's going on. So this comes up 0. Why is it 0? Well, we didn't order as much as demand, so we are going to have no discount price shirts coming up. So equals sum, and then we're just going to sum these two numbers together. So if Randy orders 1,450 shirts and demand is 1,500, then he's not going to make 26,000 because I just did revenue. I just forgot I got to take away my costs. So we're going to subtract the variable cost, and then we're going to subtract the fixed cost. And so there we go. So if he orders the 1,450 shirts, he is going to make $13,350. Now this is where the spreadsheet model is nice because we have all that set up. What happens if demand's only 1,300 shirts? I just type in 1,300, everything recalculates. You can see that we've got some discount shirts that we'll be selling. He's still going to make a profit, $13,150 at that 1,300 number. What if we go to 1,400? He's got 13,550. So it's really easy to play around with these numbers and see how things are going to change. Now, actually looking at this number here, I don't think is right. Let me double check. So my fixed costs are right. I have a small error in my variable costs. Because see what I did? Variable cost times demand. It's not demand that's going to drive the variable cost. It's how many I order. So let me go and make that quick change. There we go, 13,150. That's what I was expecting. So if we go back to 1,500 demand, he's going to make 13,750. And so it's really easy to take a look at these. So if demand is 1,450 and the order quantity is 1,450, Randy's going to make 13,750. And so, as long as demand is greater than what he's going to order, he will make a profit. This will be his maximum profit. He can't make any more than this. Anything less than that, he's going to start losing some profit. So let's say 1,450. Let's say he only sold 1,000 shirts. That profit's going to drop down to 8,350. But this makes doing these kind of decisions really easy because we can play around with the numbers and everything calculates for us in all these different situations.